On today's episode, everyone wants EVs, but where will the metals come from? Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today. Carbon neutrality by 2050. No new internal combustion engine vehicle sales after 2035. Now, we've all heard the politicians talk about this, and some nations have implemented policies, but has anyone actually thought about what it will take to replace 60 or 70 million internal combustion engine vehicles manufactured every year? Take a look at the material inputs. Like internal combustion engine vehicles, steel, aluminum, glass, rubber, and plastics will all be necessary in roughly the same proportion as they are for fossil fuel-powered vehicles. More copper will be needed, primarily due to electric motors, but the real change is in the battery. Lithium, cobalt, and nickel will be needed in significant quantities, and they're not used in meaningful amounts in gasoline or diesel-fueled vehicles. Now, automakers can retool a factory for EVs in a year, and there's now a Tier 1 and Tier 2 supplier base that can provide batteries, motors, control electronics, wiring harnesses, and everything else needed to mass-produce electric vehicles. But what about those critical battery inputs? Now, McKinsey has researched this problem, and the results look sobering. Consider lithium. McKinsey expects that the battery industry's demand for lithium will grow at an annual compound growth rate of 25% to 2030. And while lithium is present around the world, 70% of current global production is in Australia and Chile. The situation is even worse for cobalt, where the majority of production is in the Democratic Republic of the Congo, where cobalt mining is highly controversial due to corruption and human rights abuses. And prices? Well, market forces are at work, and lithium prices increased over 500% between 2021 and 2022. By March 2022, lithium carbonate and hydroxide prices had soared to over $65,000 per metric ton, against a 5-year average of $14,500 per ton. Now, new technologies are in development, such as the extraction of lithium from brines, but of the 5 different techniques for extracting lithium this way, only one, adsorbents, is in use commercially. And recycling is not predicted to be a significant source for the simple reason that the existing vehicle fleet is not large enough to create a meaningful supply of end-of-life batteries to feed new EV production, even if a cost-effective way to recover that lithium is discovered. And I'm talking about only one metal. Significantly more lithium, cobalt, nickel, copper, and other expensive metals are going to be necessary for at least a decade until enough internal combustion engine vehicles are replaced to flatten demand growth. Now, automakers like Tesla are attempting to control the skyrocketing costs by buying supply forward and investing in mineral processing companies and even in mines. Now, this kind of vertical integration is usually a sign of desperation in manufacturing, and it's risky. The other risk, of course, is geopolitical. With relatively few countries producing such a high percentage of critical materials, supply disruptions are a real possibility. So what's going to happen? Expect electric vehicle prices to remain high, which will drive auto manufacturers to build higher value electric vehicles, like large SUVs and light trucks preferentially over smaller, lower margin cars. I expect that governments will attempt to bridge the price with more subsidies and tax breaks for consumers, but most importantly, I'm watching for a change in the residual values that drive the entire automotive market. Now, $20,000 is common as a replacement cost of an EV battery. After 10 years of the ownership cycle, perhaps less for cheaper models, it's very unlikely that there will be enough residual value in the vehicle to justify this expense. The high price of battery materials and batteries themselves may make EVs essentially disposable, and from an engineering perspective, it makes little sense to engineer a durable vehicle if its battery will end its life after 6 or 7 years. Some are looking for a new type of vehicle engineering where the entire system is designed to last perhaps 7 or 8 years maximum, at which point the car is returned to the manufacturer and disassembled for recycling. Now, BMW already does this in Germany with internal combustion engine cars for environmental reasons, but if the market goes in this direction, and with current auto loan terms frequently running 5, 6 years or longer, we may be looking at a future where leasing is how we all drive personal vehicles. Now, the environment may love us, but they'll pry the keys to my Triumph TR8 from my cold, dead hands. Well, that's it for today's episode of End of the Line, brought to you by engineering.com. If you like this show, be sure to subscribe to our channel and click on the notification bell for our next episode. For our deeper engineering video series for the manufacturing professional, visit engineering.com TV to watch exclusive shows like Manufacturing the Future, not found here on our YouTube channel. The link is in the description below. Thanks for watching.